A builder decided to build a farmhouse. He employed 100 men for 35 days. So initially the amount of work that was done is 100 men working for 35 days. Then he brought an additional 100 men and completed the rest of the work in 5 days. So this 100 is already there and another 100 were brought in. So 100 plus 100, now there are 200 people and they work for 5 days. So this is the whole work. Initially 100 men working for 35 days, then an additional 100 men. So 200 men working for 5 days. If he had not employed the additional men, how many days would have been required for the whole job? So additional 100 were not brought. So if only 100 people are there, they will be working for X days to complete this whole job. So I'll cancel out the zeros. So X you will get it as 35 plus this 2 into 5, 10. So that will be 45 days. So if those additional 100 men were not there, then the original 100 people would have to work for 45 days. That is option D, 45. A school student started writing down the numbers 1, 2, 3, 4, so on, and then added all the numbers. Now if you write the numbers 1, 2, 3 up to n, and if you add up all the numbers, the total sum is obtained as n into n plus 1 by 2. That is 1 plus 2 plus 3 plus 4, so on up to n. That total sum is obtained as n into n plus 1 by 2. So we will assume that the student wrote up to n, and if you add up all the numbers, that total sum is obtained as n into n plus 1 by 2. And he got that result as 48. But when I checked the result, I found that he had missed a number. So we will assume that the number that he had missed is x. So if you remove the number x, then the total sum is obtained as 48, which is the missing number. So this number x, that is what we need to find out, and this is the equation that we have. Now first we'll multiply by 2, so all the denominators will go off. So n into n plus 1 minus 2x is equal to 48 into 2, 96. So n into n plus 1 is equal to 96 plus 2x. Now we must find out the minimum value of n such that n into n plus 1 is just greater than 96. So then we can find out the value of 2x and then x. So n into n plus 1 has to be just greater than 96. Now if you take n is equal to 10, if you consider n is equal to 10, 10 into 11 gives you 110. That is just greater than 96. So this is just greater than 96. So 110 is equal to 96 plus 2x. So this is the equation that we have. So 2x you will get it as 110 minus 96, that is 14. So 2x is 14 or x is equal to 7. So the number that he missed, x is equal to 7, option B, 7. Now earlier I had said that we must find out the minimum value of n such that n into n plus 1 is just greater than 96. Now if we do not minimize the value of n, then the value of x will become greater than n. That is not possible. Also n into n plus 1 should not be less than 96. If it is less than 96, then the value of x will become negative. So you must find out the value of n such that n into n plus 1 is just greater than 96. And you will get n to be 10. And the number that you had missed, x is equal to 7, option B, 7. In how many ways can 10 books be arranged on a shelf so that the oldest book and the newest book are always together? So altogether 10 books are there, out of which one of them is the oldest and one of them is the newest. So you can consider them as just 8 books, and then you have the oldest book and the newest book. Now the oldest book and the newest book, they should always be together. If they are together, how many ways of arranging them? Now the oldest book and the newest should be together means bring them together, tie them up and treat it as one book. So these 8 books are there and this is treated as one. Now if you treat this as one, the oldest and the newest, they will always be together. So 8 books and this one book, so effectively 9 of them. And they can be interchanged among themselves in 9 factorial ways. And in each of these 9 factorial arrangements, O and N can be interchanged among themselves in 2 factorial ways or in 2 ways. So these are the number of arrangements where the oldest and newest are always together. That is 9 factorial into 2. That is option C. There are 10 green apples. I'll just mark it here. Green, there are 10 of them. 7 yellow apples. Yellow, there are 7 of them. And 5 red apples in a bag. So red, there are 5 of them. You are allowed to pick them out one by one. But you are not able to see the color of the apples while they are picked out. How many apples do you need to pick to make sure that you have at least 3 red apples? So you have to ensure that there are 3 red apples. Now to ensure that there are 3 red apples, we have to look at the worst case scenario. Now the worst case scenario is like this. The first 10 apples are, let us say, green. Now the next 7 are, let us say, yellow. So now you have picked 10 plus 7, 17 apples, and you haven't got any red apples. And the next 3 compulsorily will be red. So if you pick 10 plus 7 plus 3, 20 apples, you can ensure that there are at least 3 red apples. So this is the worst case scenario, and you must consider the worst case scenario because you have to ensure that there are at least 3 red apples. For example, if you pick only 17 apples, it is possible that the first 10 are green and the next 7 are yellow. You won't have any red apples. So to ensure that you have at least 3 red apples, you need to pick 20. Then for sure you can say that there will be at least 3 red apples in them. So number of apples that you need to pick is 20. That is option C, 20. 2 series are given. What is the sum of the first 100 numbers common to both the series? So I'll write down the series here: 5, 8, 11, 14, 17 and so on. So I'll just continue with the series. Each number is obtained by adding 3 to the present number. So 5 plus 3 is 8, 8 plus 3 is 11 and so on. So 17 plus 3, 20, then 23, 35 and so on. Now let us write down the second series, that is 5, 7, 9, 11, 13 and so on. Each successive term is obtained by adding 2 to the present number. 5 plus 2 is 7, 7 plus 2 is 9, like that. So it will be 15, and so on. Now what is the sum of the first 100 numbers common to both the series? So we must find out those numbers that are common to both the series. So here you can see 5 is common to both the series, 11 is common, 17 is common, then 23 is common and so on. So if you write down the numbers that are common to both the series, that will be 5, 11, 17, 23 and so on. You can see that this also forms a series, and each successive number is obtained by adding 6 to the present number. 5 plus 6 is 11, 11 plus 6 is 17, 17 plus 6 is 23, like that. So the next one will be 23 plus 6, 29, then 35, 41, it will be like this. So we must find the sum of the first 100 numbers of this series. This series consists of all the numbers that are common to both the series. Now sum of the first n terms of a series is given as Sn is n by 2 into 2a plus n minus 1 into d. This is the formula for the sum of the first n terms. Now n is equal to 100. First term a is equal to 5 and common difference d is equal to 6. So we'll just substitute the values and calculate the value of Sn. That is equal to n by 2. N is equal to 100. So 100 by 2 into 2a. So that is 2 into 5 plus n minus 1. N is equal to 100 into d. That is n minus 1 is 99. 99 into d is 6. I'll just bring 2 inside. So 2 cancels out with this 2. Here 2 divides 6 3 times. So what we have is 100 into 5 plus 99 into 3. That is 297. 297 plus 5 is 302. Into 100 gives you 302 followed by 2 zeros. So that will be the sum of the first 100 numbers common to both the series. 302 followed by 2 zeros. That is option A.